Okay, so this video is on section 2 of chapter 2. We're going to be talking about speed and velocity. So let's go ahead and pull this up. All right, so in the last section, we described motion in one dimension, and we talked about the difference between displacement and distance, and that speed was your distance divided by your time. So that's what speed is. Speed is referred to as the rate of motion. So it looks at how fast or how slow something moves. And the formula, or how we determine speed, is we're going to take distance and divide it by time. So our units are meters per second. Speed is always positive. So that's something to remember. Speed is always positive. Okay, come on. I need you up here. There we go. All right. Velocity, on the other hand, right? So speed is distance versus time, but velocity is displacement divided by time. So displacement divided by time is our average velocity. So there's your difference between speed and velocity, or one difference. Speed is distance divided by time. Velocity is displacement divided by time. Units wind up being the same either way. Average velocity describes how fast something is moving, but here's the other big difference, is it also describes the direction in which it moves. So speed is a scalar quantity, whereas velocity is a vector quantity. Okay, so an object moving in positive direction will have a positive velocity. Object moving in the negative direction will have a negative velocity. So if you think about that motion in one dimension, like we talked about, on the x-axis, here's our origin. So if our velocity is moving in the positive direction, then we are going to have a positive value for our velocity. But if we're going in the opposite direction, if we're going in that negative direction, then we will have a negative value for velocity. The sign is going to indicate the direction in which we are moving. So if we talk about a position versus time graph, that's another way of representing data in a data table. Hang on, I just skipped to a whole new section. Yes, I did. So we will do section 2 and 3 together because that was super short. All right, so position versus time graph is just another way of thinking about data in a table. So if we have a table that measures our distance versus our time and our time, we can put that data into a graph and measure a position time graph. When we do that, that's going to help us very easily see a relationship between those two things. In position versus time graph, position is always on the y-axis, time is always on the x-axis. So here is our example of that. So here's our data in table form, and then we simply plot it. And again, time is going to go on the x-axis, position is going to go on the y-axis. And we can look at that graph and get a lot of valuable information. We can see that it's a direct relationship, it's a straight line plot, a linear plot. And so that means it's a linear relationship between position and time. We always use a line of best fit because most of the time our graphs are not going to be as nice and neat as the one that was just drawn on the screen. Our points are going to be kind of all over the place. Okay, so if that's time and that's position, rather than, we're not going to connect all those dots. Instead, we're going to draw a line of best fit, which means I draw a line through the middle of as many of them as possible. And that will then give me my linear equation. That will tell me my slope and those kinds of things. Okay. All right, so let's click that off. So to find position at a time not in the original data table is another reason we like to use a graph instead of just the table, is because we can get more information. We can make predictions about what the time or position will be at some point not necessarily listed in the graph. So let's talk about how to do that. So if we're talking about a point that's given on the x-axis, like 2.5 minutes instead of 2, or 2.5 seconds instead of 2 or 3, we're just going to go to that point on the graph, go up to the line, and go across, and that will tell us our position. If we're talking about a point not on the line, so if we're talking about 6 seconds, which is way over here, we do what's called, this is called an interpolation, because I'm looking at what's going on within the data, in between the data points. And this is called an extrapolation, because we're referring to things happening outside of the data table. So I do the same thing though. Here's my point, I'm going to go up till I would meet that line. If I could take that line and extend it on out to a point that would meet that line, and then I go across. So at 6 seconds, I'm predicting that my position will be 3 meters. All right. So the slope of a straight line is equal to its rise over run. So remember, that's one of the ways we've learned in math of how to find slope. Slope is rise over run. And we can use any 2 points on the line or on the graph or in the data table to find slope. On a position versus time graph, the rise, of course, is going to be your y-axis, and your run is going to be your x-axis. So your y is going to be your position, and your time, your x-axis is going to be your time. Oops. All right, so we can look from the graph and determine the slope of the graph that way, just by going across and up. So my rise would be 1.5 meters, because I'm going from 0.5 to 2. So 2 minus 0.5 is 1.5. And then across, I'm going from 1 to 4. So 4 minus 1 is 3. And I'm going to divide those two things out, and that will give me the slope of my line. A straight line represents a constant slope. And so it also then is going to represent a constant velocity, because velocity, remember, is displacement or position over time. I should write that as change in x over time. So on a position versus time graph, if we get a constant velocity, over the slope of our line is our velocity. Because we look here, we're changing the position, dividing it by time, which is what velocity is. Change in position over time. So here's a graph that's not necessarily a straight line, but I can still gain a lot of information from that graph. A straight line on a position versus time graph can either be a positive slope, a negative slope, or zero slope. So if you look at this graph here, as we are increasing, that's a positive slope, which would mean we have a positive velocity. And then it goes flat right here, which means we have no slope, which means we have no velocity. And then as it's coming back down the other side, we have a negative slope, which means a negative velocity. A negative velocity would mean you are slowing down. Positive velocity would mean you're speeding up. Zero velocity would mean you're holding constant. Okay. All right. The greater the slope of the position versus time graph, the greater the velocity. So greater the slope, greater the velocity. And if we have a tangent line, the slope of that tangent line is going to be equal to what we call the instantaneous velocity. So let's say I have this kind of graph. So a tangent line is one where we take one particular point and we draw a line that goes through that point. So the slope of that line is going to be our instantaneous velocity. Instantaneous meaning it's going to be the velocity at just that one particular moment in time. Okay, and that takes us through 2.3. Alrighty.